Welcome to the seminar called Micro-3D Computer Graphic at 10 MIPS. This part shows how to implement projection and rotation with matrix multiplication. I will illustrate this with help of LabView. LabView has two windows, one for indicators and controllers, called front panel, and one for program, called block diagram. To show a graph, I will just place a graph indicator on the front panel, and the program module will appear in the block diagram. The same will be if I control something. I place the controller in the front panel, and the program module will appear in the block diagram. To draw a polygon, I need a polygon module and a polygon to be drawn. To program in LabView, I just draw lines. If an error occurs, it will be indicated by a cross over the line. Here it says I can't mix array with cluster. So I add a converter to correct it. Now I got two errors, which says the converter doesn't work on arrays of vectors. So I have to split the array by an LO. No polygon, no errors. I check the content. The result only contains two vectors, so they're splitting in the wrong direction. So I flip the array. Now we can see the tiny little square in the upper corner, which I can resize and move by just adding an offset and multiplying it with a scale factor. Now I will make use of the matrix multiplication by adding the module. I start with the turning matrix, which is built up of sinus and cosinus, and connect those to the controller. The output is formed as a 2x2 matrix. Now we can try to turn the square. Look nice, but we want to do more. First, I used sub-function grouping to save space and make the program more visualized. The seminar was about 3D, so we had to add another dimension to the polygon. Then I have to add the same dimension to the turning matrix. This matrix will only turn around one axis, so add two more turning matrices for each other axis and multiply them together. I add two more controllers and then turn polygon around the y-axis. It doesn't look especially 3D, so I add some more surface polygon. The error indicates I can't use a multi-polygons without the loop, so I add one. The two polygons are made as the opposite side of a cube. You can see that when I turn them around the z-axis, but it still doesn't look so much 3D. So I add another side of the box, I grouping the polygon and adding the remaining side of the box. I even group the turning matrix to one sub-function. Now we'll add depth to the 3D view. I first add the matrix multiplication, and then I add the depth matrix and set the distance to 4. As you can see by the error indication, the dimension of the depth matrix is not the same as the turning matrix, so I have to add another dimension to the turning matrix and to the box polygon. Now we have to extract the depth view from the polygon and scale the drawing part by it. As you can see, the cube has got a perspective. From the scaled side, we can extract the perpendicular vector to the surface and decide the direction of the z-axis. By only drawing polygon with positive z-axis, we can hide non-visible side. To clarify the program, I make the inner part as a subfunction. Now I will give the cube a more 3D look by adding the surfaces. First I will turn on the filling function. Then I make a multiplication to a virtual vector, which represents the light source. I adapt the result to fit my grayscale. I convert it to a color and fit it into the polygon drawer. Now when I turn it around the y-axis, you can see the light on the surfaces changes. Now I will add another matrix multiplication to make them moving. I add the moving matrix and move it 8 steps further away. This will make the box look smaller because depth projection. Then I set the time to control the x-axis in motion. And by changing the rotation and add some more time control features, we can get animation. So that's all for this time. Watch out for the next part, which will be about human perception.